Yes, so my name is Nader Dabit, as Yanni mentioned, and I'm a developer advocate for AWS, Amazon Web Services, and I'm going to be talking today about building full-stack React Native applications in the era of what we are currently in, that I'm going to be calling full-stack serverless, but basically full-stack in the era of serverless computing. There we go. So I probably should fix that.
How come none of you told him that? Like, you were just going to let him go through the whole presentation with that on?
That actually wouldn't be bad. So, I'm guessing I can probably, there we go. All right, so today, the talk is going to be split up into two main parts. First, it's going to be a presentation kind of talking about really what full stack in React Native in the era of serverless computing means, like what is full stack serverless. And then second, I'm going to go into a demo and show how to build out this type of applications. My name is Nader Dabit, but I'm Dabit3 on Twitter, GitHub, and Medium, and I do a lot of writing. I'm very involved in the React Native and more recently the GraphQL community. I'm the host of React Native Radio and the GraphQL Patterns podcasts. And my book, React Native in Action, was actually very recently published by Manning Publications. And today I'm actually really happy to announce that I'm going to be writing a new book. I got confirmation this morning called Full Stack Serverless, and it's going to be with O'Reilly Publications. And we're going to start writing that over the next couple of weeks. And hopefully the initial version to purchase digitally will be available in a couple of months. But I'm a front-end developer by trade, and I've been working with AWS for a little over a year, and I'm a bit of a futurist. You can just ask Yanni. And I'm really interested in what is happening, not only now, but maybe a year from now, 5 years from now, 10 years from now, whatever. And in late 2017, I was running a consulting company called React Native Training, and I was doing really well. But I had the opportunity to see what AWS Mobile, the team that I'm on now, was actually working on, and I immediately, really automatically knew that that's where I wanted to be. And I think that's the future of where not only cloud computing is headed, but software engineering in general. And that's basically what I'm going to be talking about today. And when people think about AWS, rightly so, they probably don't think about front-end development or front-end developers. They typically think about servers, DevOps, anything back-end. They don't really think about front-end. But the team I'm working on at AWS is actually specifically focused on building applications for front-end developers and tooling for front-end developers. And even though what I'm talking about today is going to be demoed at the end in AWS, these types of applications and the tooling and things around it are not specific to AWS. You can actually do this with other cloud providers. You can do this just gluing together a bunch of different things. So this isn't really specific to AWS. And there are three main takeaways that I'd like you to have at the end of this talk: the what, why, and how of full stack serverless. So what is full stack serverless? Why should you care? And how to actually build applications in this way. So the first idea that I'd like to talk about is the idea of reducing complexity and basically reducing code in general. And we're going to be doing this by intentionally taking advantage of smart abstractions and smart services. Basically, the idea is this: code is a liability. When code is reduced or diminished, we can more easily and quickly jump in and out of projects. We can build things faster. We don't have as much cognitive overhead when we're building things. And because there's less code, by nature, there are going to be less bugs. Really, the bottom line is only the feature that our code delivers as an asset. The code itself is not an asset. So how can we achieve robust, modern applications, have more features, and do so with less code? That's kind of going to be what we're going to be focusing on. And the second idea I'd like to drive home is developer velocity. When we're able to move more quickly and just build, morale on our team increases, our users are happier, we're happier as developers, and experimentation also increases because the liabilities that are kind of part of this whole process are decreased, and we're able to try new things, experiment more. We have less issues that we have to actually deal with because we've spent less time writing all this code. Failure has less of a negative impact in general. So let's talk about the evolution of cloud computing, and then we'll jump into how can we actually take this to the next level. When companies and developers used to ship applications, we used to keep our servers locally. This means we're reliable not only for our applications, for our software, for our code, but also for the hardware that our software ran on. We were in charge of keeping up with our hardware safe. We had to keep it secure. We had to deal with environmental hazards. We had to deal with internet outages, all this stuff that we no longer have to deal with. Also, there was no such thing as dealing with CDNs, caching, edge computing, all of these things that we kind of take for granted today were not really available. And this was really referred to as on-premises. And then over the last 2 decades, we've started moving applications to the cloud. And in reality, these are just off-site, data centers and distributed data centers that manage our core infrastructure. We no longer have to deal with things like environmental hazards, but we do still have to deal with scalability at this point. These things are not automatically going to scale for us. That's what we're going to be talking about in just a moment. And next, we had the idea of serverless. Serverless has come around in the last few years, and with the introduction of serverless, another level of abstractions was added, and it kind of introduced a way to do away with the need to maintain uptime, deal with server patching or maintenance, or even scaling it at all. So scalability was automatically now part of the package of serverless. And this gave us the opportunity to also spin up compute power on demand. So we are no longer paying for, really at the cloud computing level, we're no longer paying for actual cloud hardware. We're actually paying for compute time. So what comes next after serverless? And that's kind of what we're going to be talking about and focusing on now. And I think, really what I think is a front end and back end are moving closer and closer together. And I'm going to take a look at what a modern definition of serverless is. A few months ago, Berkeley came out with a paper. The paper was called Cloud Computing Simplified, a Berkeley view of serverless computing. And the main point of the paper was this: serverless computing will become the default computing paradigm of the cloud era, largely replacing serverless computing and therefore bringing closure to the client-server era. But really what caught my eye was how they defined serverless computing. They defined it as not just functions as a service, Lambda functions, what we might think of, but they defined it as functions as a service combined with backends as a service. Basically, stateless compute with stateful, globally available, managed, centralized services. So what are some of these centralized managed services? These managed services basically assume responsibility for providing a defined set of services, and they're serverless in the sense that they inherit all of the characteristics of a traditionally serverless application. They scale seamlessly, no server ops, etc. But most importantly, they are essentially codeless. A few examples of this are things like Auth0 and Okta for managed identity, Algolia for managed search. We have things like Google Cloud Store and Firebase and AWS AppSync for managed APIs. And we even have things like AWS has recognition, and there's other machine learning and AI services that are available. And even we have Sumerian, which does things like AR and VR. So really what happens is the question when we blend all of these new serverless tools and technology with cutting-edge front-end frameworks. And that's the idea of what I'd like to introduce as the idea of full-stack serverless. Full-stack serverless, I believe, is the next step in the evolution of cloud computing, and it's what I believe is the future of software engineering as we know it. And it's not exclusive to AWS. In fact, I'm going to be talking about some other ways that you can actually apply this. But these apps can be, really built in a couple of different ways. And really is the definition of front-end, back-end, and DevOps and full stack, like what are these different roles? Like they're changing a lot lately, and I think they're kind of converging and they're overlapping quite a bit. And what are the characteristics of full stack serverless? First of all, I would say if you're going to be looking at different things that fall into this category, a CLI for creation and configuration of services, a client library for handling interaction and cloud interaction logic, heavy use of managed services, serverless functions to kind of fill in the gaps. So you basically, what cannot be done with a managed service, you end up using a serverless function. Your front-end skill set is becoming more and more valuable, and you can see that in the job market right now. There's a deliberate focus on creating value and features versus reinventing the wheel. So you're not recreating authentication services. You're not recreating APIs and database services. These things are already there. They're managed by people that have been doing this for years. You can just subscribe to their APIs. And then really the definition of what all of these things are begin to blur. And I think we're going to see in the future, not front-end, back-end DevOps, but just developer. And a developer is going to be, you as a developer are going to have to deal with a bunch of things versus just being specialized at a single thing. So, what are some of the benefits of doing this? Well, as a front-end developer or as a mobile developer, we can kind of move further up the stack. We're no longer just implementing client-side code. We're no longer limited to just implementing other people's APIs. In the past, each of these features took competent back-end engineers weeks or months to build. And since we're only working with really a predefined set of API calls and serverless functions, we can actually write all of this in JavaScript. So we can build using our existing skill set. And we can hook into these services and implement these features with little or no knowledge of the actual back-end implementation. So we're not worried about how they wrote their code. We're worried about how we can interact and get value out of these features. The architecture that I'm talking about is the ultimate enabler of developer velocity. It enables us to iterate much more quickly and cheaply, allowing us to really experiment a lot more with a lot less liability. And then a lot of these services, or most of them, are actually essentially codeless. Because these services are created and managed by a third party, they require almost, for our part, to write no back-end code at all, meaning our entire application has less code, and with less code comes less complexity. This moves the discussion really from what we hear a lot as managing complexity to actually removing complexity entirely. And really, this complexity is still there. It's just not our problem anymore. It's not in our code base, and it's in someone else's code base. And I really like this quote from Ben Kehoe, and he's really someone to read up on Medium and some of his articles he has written around this topic. And he says, "We've spent so long crafting Swiss watches that we fail to recognize the advent of the quartz Casio and impugn the evolution as lacking in elegance." Basically, things that just work, we as developers tend to overthink things sometimes, and we want to create our own version. You see this a lot in the JavaScript ecosystem. That innovation is actually really good, but a lot of times if something is working, there's no reason to reinvent the wheel. And these services are typically more secure and more stable than rolling our own would be. There's specialized teams of engineers building this stuff out. These engineers are building something that's like their core competency. So they're building something for years like that they specialize on. They've hit every possible issue that you probably could think of. And the issues and problems that they've solved are usually kind of like unknown unknowns that really come with scale that you may not see until you actually, it's too late and you reach that scale. And the paradigm in general just lets you focus on writing your business logic and not coding supporting infrastructure for that logic. And you can then basically focus on creating value, and you can apply this technology towards the creation of value. The bottom line is the creation of value. And how can you do this? There are a couple of different ways that I believe, or a couple of different companies and things that you can use that are starting to fall really into this category. I work for AWS, so I'm going to be talking about AWS Amplify framework, but there's also Zeit. Zeit has Now, and they have Next.js, and they have a lot of really interesting things happening with the serverless space. The Jam stack, I believe, kind of falls into this category as well. Jam is JavaScript, APIs, and Markdown. And things like Netlify and a lot of the associated technologies around the Jam stack there. And then Firebase has kind of been doing this type of thing, and now they're adding, Google has Cloud Functions and a lot of different machine learning and AI services that they're adding as well. And I'm going to focus on the Amplify framework, and my team is really focused entirely on building a framework around these types of applications. And there are a couple of main pieces. The first is a CLI that allows you to create, configure, and update cloud services directly from your command line. Some people kind of think of it as a Rails for backend services. There's also a client library that then allows you to connect to these services. So from the command line, you spin up a service. From the client, you interact with it. And then the CLI has additional features other than just a generation process. We have something called GraphQL code gen that you may have used if you've used GraphQL in general. We'll introspect your GraphQL schema, and we'll then generate all of the local code that you need. We also have the GraphQL transform library that allows you to deploy sophisticated GraphQL backends using our custom directives. So here's a list of some of the services that we offer right now. The ones that I'm going to be focusing on are GraphQL APIs and authentication. But we do quite a bit more. We added recently a plugin for video streaming, serverless functions, OAuth. We've made some improvements there in the last couple of weeks. We also support native iOS and native Android libraries. And most importantly for React Native, we actually have client support for React, React Native, Vue, and Angular. So if you're a React Native developer, we have a few UI components, and they're really platform-specific components in general that scaffold out a bunch of functionality, a bunch of UI with only a couple of lines of code. So things like authentication, things like chatbots, things like photo pickers, photo albums, AR and VR scenes. You can do all of that with the framework-specific library. So you would have AWS Amplify and AWS Amplify React Native if you're doing React Native. If you're doing Vue, each one has its own specific target. So I'm going to go ahead now and jump to a demo. And I'm going to start with a blank React Native application. And from this React Native app, I want to generate I want to add authentication. I want to add a GraphQL API. I want to be able to add CRUD operations, and I also want to list items from our API. So how can we do that using this framework in just a few minutes? And it looks like we have about 15 minutes to do so. I'm going to start off in a blank React Native project. And here I have initialized a new Amplify project by running Amplify init. And after you run Amplify init, you can just run Amplify status. And this will show you the current status of your Amplify project. Here we're going to see a list of features that would be there had we added them. Since we haven't added any features yet, there's nothing there. So we'll start adding features. So the first thing I want to add is auth. To do so, I can run Amplify add auth. Here it's going to walk us through a couple of steps. We can either do a default configuration, which is a quote-unquote smart configuration that gives us a bunch of defaults, or we can define our own. I'm going to take the default. We're able to specify here now what we want to use as the username, or what we want to use for the user to sign in. I'm going to use username. Then we can start requiring attributes that need to be gathered on sign up from the user. So say you want to capture their address or any custom attributes, you can define those here. I'm just going to stick with email. So now that we've done that, we've successfully added the feature locally. It's not yet in our actual account. To create it, we have to run the push command, which would be amplify push. But next, before we do that, I want to add a GraphQL API. So to do that, I'm going to run amplify add API. So here we're given the option between REST and GraphQL. The REST API is basically a combination of a serverless Lambda function and API gateway, but we don't want that. We want GraphQL, so I'm going to choose that. Here we can give the API a name. We can choose the authorization type. We right now support API key, which is basically open auth. Anyone with the API key in the header can hit our API. We also have Amazon Cognito user pools, and we have OpenID Connect. So I'm going to choose API key for now. Do we have an annotated schema? If we did, we can just reference the schema location. We don't though, so I'm going to go ahead and do a guided schema creation. Here we'll be given two boilerplate options. One is a basic, really basic type with a few different fields, or we can do one-to-many relationships. I'm going to choose the basic type, and I do want to edit the schema. This should go ahead and open our schema in a text editor. From here, we can define the application that we'd like to build. The app that I want to build is going to be a conference app. So we can keep up with different speakers and the speaker titles and what they're going to be talking about at the event. So to do that, I'm just going to go ahead and scaffold out a quick schema that is going to be a type of talk. The talk is the main type of the app. The talk has a talk name, a speaker name, and a speaker bio. You also see this @model decorator or directive. This is what the GraphQL transform library is going to use to deploy the entire backend. Typically with a GraphQL API, you need a bunch of basic CRUD operations to get started. You might want to create a talk, update, delete a talk, list talks. You might even want to create GraphQL subscriptions. We'll actually build all of that schema for you. We'll create a data source, and we'll write the resolvers that map between the data source and the operations. So I'll go ahead and save that, and I jump back to my command line, and I hit enter. We'll notice that the API was successfully created locally, and now to create the two different services, the authentication service and the GraphQL API, we can run Amplify push. Here, we're given the operation that's about to happen, create. We see that there's two new features that's going to be added. We want to continue, we can choose yes. And this is going to go ahead and introspect our schema, and it should go ahead and now prompt us whether or not we want to go ahead and do GraphQL code generation, depending on how good my Wi-Fi connection is here. If this does not continue because I might have some Wi-Fi issues here, I actually have a next step where this is already completed. So after that's completed, it will actually prompt us for GraphQL code gen, and you can specify where you want the code gen to happen. Do you want TypeScript, Flow, or JavaScript, all of that stuff. After that happens, we will have the Amplify folder, but we'll also have this AWS exports file. So these two things are created for us by the CLI. The Amplify folder holds our two different feature definition code and everything that goes along with it. Our AWS exports file is something that keeps up with the location of our resources. So if I look at AWS exports, you can see that we have all of these different properties that are kind of defined for us. So now that we have all of that there, we want to go ahead and start interacting with the API. So I'm going to go ahead and open up the app in a text editor here. You'll see that we have this GraphQL folder. This was created by the CLI, or would have been. And we have queries, mutations, subscriptions all kind of generated for us. So the first thing we want to do is we want to add authentication. So I'm going to start with this very basic React Native app, and what we're going to do is, first of all, we're going to configure in index.js the Amplify project. The way that we do that is we import Amplify, we import the configuration from AWS exports, and we call amplify.configure. That's it. That's all you need to do to kind of configure everything. Now we can start playing around with some of the features. The first thing, again, I want to add is authentication. So to do that, I'll go ahead and import the platform-specific with authenticator component. So we import with authenticator from AWS Amplify React Native. This allows us to kind of scaffold out an entire authentication flow with just a single line of code, really, or import plus one line of code. So instead of exporting the class as the default export, we're going to instead export the with authenticator as the default export. So here we have export default with authenticator. We pass in the component we'd like to authenticate, and then we can pass in some configuration. Include greetings just allows us to have the user's name pop up with a sign out button after they've signed in. So now when I refresh, we should now be prompted with the sign up flow. So I want to go ahead and sign up. this email needs to be real, or else it won't work because we're going to be doing multi-factor authentication, which is kind of built in. So in my email, depending on how slow this internet is, I should get a authentication code in my email. So now if I paste that there, I should confirm and be logged in, or signed up. So now I can log in. All right, so we're now signed in. We have a greeting there and a sign out button. If I refresh, we stay signed in. The next thing we want to do is add the GraphQL API. So what we want to do is we want to import the operations for the GraphQL API. So we need to import the mutation and query and subscription definitions. We then need to call the API when the app loads. So we'll in component did mount. We'll fetch the data from the API. We'll set some state. We'll then update our UI with the different UI we'll need for like a real form and a list. And then we'll add some basic styling. And I'm going to do this all with some snippets that I already have. So here we're importing API and GraphQL operation from Amplify. And then we're importing button and form input from React Native Elements. This is just so we don't have to write out a bunch of design stuff. These are the queries, mutations, and subscriptions. Next, we'll define some initial states. The state is going to be a talks array, a name, a speaker name, and a speaker bio. Next, we're going to have in component did mount. We're going to go ahead and fetch the talks data from the API by calling api.graphql. api.graphql returns a promise, so we're doing async await. Here we'll take the talk data and we'll reset the talks array with that data. And then we'll have some methods for, first of all, onChange for updating the state when the user types. And then we'll have the createTalk method that calls api.graphql and passes in the talk, which we created here as an object, just containing the name, and speaker bio. And then we do an optimistic response by also updating the state before the actual API call is successful. Here is just a bunch of UI. This is stuff, if you've used React Native before, you know what it is. It's a form, so it's basically 3 inputs, a button, and a list. The list is iterating over the talks and just kind of rendering out the talk name, and speaker bio. Finally, in the styles, I'm just going to do some new styles. And then I think I also need to import the scroll view. All right, so let's refresh and see if this works. All right, so now we have a form. We don't have anything there, so let's create a talk. So the talk looks like it's created, but let's refresh to make sure it actually works. So if I refresh, boom, it's there. Next, let's add real-time with GraphQL subscriptions. This sounds pretty hard, right? So I add this code right here. We basically call api.graphql, just like we did before, but instead of returning a promise, we call .subscribe on the actual method. Every time a subscription is fired, we get the data available in this next function. Then we update the local talks array, and then call setState. And to test this out, let me go ahead and refresh now that we added that. I'm going to go into the AppSync console. This is where we have our graphical editor, all the stuff associated with your API that you can go test it out with if you'd like. So I'm going to create a new mutation. This is going to be create talk. The name is going to be real time. The speaker name, speaker bio, Finn. Here we'll just return all of the things that we need in the actual client application. So we'll do speaker bio, speaker name. Boom. In the actual API, since we're subscribing to changes, anytime a new talk is added, our client is listening for it. We added that GraphQL subscription stuff in only about 15 lines of code. And actually, this could have been a little less if I had written my client a little better, and we had included a unique client ID. So whenever we created a new talk, we could just filter out based on the client ID. But anyway, so yeah, subscriptions, we added that also in just a couple of seconds. And I think that's about it. I know that you can probably see that, so I'm going to go ahead and jump to the resources. So if you'd like to learn more, I'm going to be tweeting out this slide deck, and I am Dabit 3, so you don't have to write all this stuff down. But I'm Dabit 3 on Twitter. We have the just regular documentation. It's a great place to go. We also have awesome AWS Amplify. We have a couple of articles written by me. One of them I would definitely check out if you're interested in this stuff. Full stack development in the era of serverless computing. And that's it. Thank you.